All right, welcome to 2.4, part 1. Today we are going to be covering these three learning targets. It involves slope, slope-intercept form, and then writing that slope-intercept form from different situations. All right, so in our notes, we are going to be going over the slope formula, and that is what you use if you're given 2 points and need to find the slope. So your 2 points are x sub 1, y sub 1, and x sub 2, y sub 2. So remember, slope is rise over run. So that's why it's the difference in the y's over the difference in the x's. Rise, y's over run. And then slope-intercept form combines the slope and the y-intercept. The y-intercept is the point where your line crosses the y-axis. And then point slope form is helpful if you're given just a single point and the slope. So point slope, if you have the slope and a single point, you will want to use that. All right, so let's practice using these. So let's start. We want to write the equation in slope-intercept form of a line with a slope of 3/4 and a y-intercept of 5. If you are given your slope, that's going to be your m value. If you are given the y-intercept, that's going to be the b value. So if you are given m and b, all you have to do is put it into the slope-intercept form. So we're going to use y equals mx plus b. And substitute 3/4 in for m, x plus 5. So if you're given slope and y-intercept, you can use slope-intercept form. Slope, y-intercept, slope-intercept form. All right, if we are given a graph, if you have a graph, you can use the graph to find your slope and your y-intercept. So then we can just use y equals mx plus b. So m is change in y over change in x. So in order to do that, you want to find 2 points on your line and find the rise and the run. Rise over run. So your rise here, between this point and this point, you are going down 1, 2, 3. So your rise is -3. And then your run, you're moving to the right 1. So +1. So if we simplify that, your slope then is -3. All right, then your y-intercept, your b value, that's going to be where this graph intersects with the y-axis. So your graph here intersects with the y-axis right here, and that looks like it's at -1. So if we write our equation, y equals slope, -3 times x, plus your y-intercept, -1. And you can leave it like this, or you can write it as -3x minus 1. Always remember to have the y equals at the beginning, and don't forget to put your x in there. All right, now to write an equation of a line that goes through these 2 points, we're going to need the slope and the y-intercept. So this is going to be a 2-step problem. So first we need to find the slope, and we're going to use, since we are given 2 points, we are going to use the slope formula. So this point can be labeled x sub 1, y sub 1. This point can be labeled x sub 2, y sub 2. And to find the slope, I'm going to do y sub 2 minus y sub 1. So -3 minus 1 over x sub 2 minus x sub 1, -7 minus -5. So -4 on top. Subtracting a negative is the same as adding a positive, so -7 plus 5 is -2. -4 over -2 simplifies to a +2. So that's my slope. Now I have slope and I have 2 points. In order to write an equation, I can use point slope form if I have slope and at least 1 point. So I'm just going to use my x sub 1, y sub 1 in my point slope form here. So it's going to be y minus y sub 1, which is 1, equals slope 2 times x minus x sub 1, which is negative 5. Now we want these in slope-intercept form. So what I have to do now is I have to distribute the 2 here. And this minus negative 5 is really plus 5. So it's going to be plus 10. And then add 1 to both sides. So y equals 2x plus 11. So that is my slope-intercept form. Number 4, a line through those 2 points. So see if you can use the process we just used in number 3 to write the equation for this line in slope-intercept form. So pause here, try that, and then come back to see the answer. So I'm thinking you started this problem and you did y sub 2 minus y sub 1, which gave you a 9 on the top, and then x sub 2 minus x sub 1 gave you a 0 on the bottom. You cannot divide by 0, so this is called an undefined slope. If you're ever dividing by 0, that's an undefined slope. If your slope is undefined, that means you have a vertical line. So if we were to graph this, let me sketch one out here. Here's a graph. And we have the 2 points 4, negative 2, right here. And then 4, 7. Let's say 7's up here. 4, 7. You can see that they are vertically going through the same x value. They're both going through x equals 4. So if you get an undefined slope, you have a vertical line, and the equation of that vertical line is just going to be equal to the x values. See how they go through the same x value? That means the equation of that line is going to be x equals 4. All right, now writing equations from a table. First, we are going to use the table to find the slope, and if possible, see if the y-intercept is also in the table. If the y-intercept is not in the table, then we can use our point-slope form. So to find the slope from a table, it's rise over run, which is change in y over change in x. So let's see, between these 2 points, our change in y here is from negative 10 to negative 7. It looks like that's going up 3. And then from negative 2 to 0, that's going up 2. So rise is the change in y. So your slope is 3 over change in x, which is 2. So your slope is 3 over 2. Now, if we're looking for our y-intercept, we just have to look where the x value is 0, because if you look up at a graph here, if we go back up to this example, this graph, that's where x is 0 and y was 1, so that point is 0, negative 1. So if we go down here, and in our table, x is 0, that's going to be your y-intercept. So our y-intercept here is 0, negative 7. So that means b equals that y value of negative 7. So since we have slope, which is m, and b, we can just put that into our slope-intercept form. Y equals 3/2 x minus 7. You could also write that as plus negative 7. All right, let's look at this linear table. So again, we are trying to find our slope first, which is rise over run, or change in y over change in x. So change in y is 5 to 5, well, that's 0. Change in x is negative 1 to 2, which is plus 3. So here we have a slope of 0 over 3. Now, when your 0 is on top, that's okay. You can take 0 and have that on top. That just means that that ratio is equal to 0. So if your slope is 0, you have something called a horizontal line. Okay, if you have a horizontal line, let's just graph those 2 points so you can see. If you have a horizontal line, let's see, -1, 5, and then 2, 5. There are those points. You can see they're going through the same y value, and you can see here the y values are the same. So if the y values are the same, that horizontal line is going through y equals 5. So that is the equation then for a horizontal line when your slope is 0. All right, let's look at a word problem now. This is going to be our third learning target. Tony is finishing a scarf at a constant rate. So that's going to be our hint for these linear equations, constant rate. The table shows the number of hours Tony has spent knitting the scarf and the corresponding number of rows in the scarf. Express the number of rows as a function of time. So since it's a function of time, that means hours is our independent variable. So that's going to be our x. And then our rows of knitting depends on how long she has been knitting. So that's your y, your dependent variable. So as a function, anytime we see function, we're going to go back to function notation. So we'll call this f of x. And it's a constant rate, so we know it's going to be linear. So we're looking at mx plus b. All right, so we're looking for our slope and our y-intercept here. Well, to get slope, you're going to take your change in your dependent or change in your y, your rise, over your run, your change in your x. So now that we know that rows of knitting is y and number of hours is x, we're going to do change in y. So 38 to 44 is a change of 6 plus 6. And then from 2 to 4 is a change of 2. So our slope, m, is going to be 6 over 2, change in y over change in x, rise over run, equals 3. So your slope is 3. Now on here, we don't have how many rows she had knit at 0 hours. Now, as you can see here, since this table is going up by 2 every time, one way you could find that b value or that y-intercept is to just go back 2 hours. So if we go back to 0 hours here, every time you go up 2 hours, it goes up 6 rows. Well, if we go back 2 hours, that means it's going to go down by 6 rows. So at 0 hours, she would have had 32 rows of knitting. So that's one way you could find B. Another way you could have done it was by using the point slope form like we did up here in this previous example in number 3. All right, so B is 32, slope is 3. So our equation, our function, if you will, is going to be f of x equals 3x plus 32. So what this means is when she started knitting, she already had 32 rows of knitting, and she knits 3 rows every hour, or 6 rows every 2 hours. Now, how many rows will she complete in 10? To get how many rows she completes in 10, we just have to substitute 10 in for x, the number of hours. 3 times 10 plus 32. So that ends up being 30 plus 32, which is 62. Now, this is a real-world situation, so she will have knitted 62 rows in 10 hours. All right, so think about today. Think about what did you know when you came into today? What was new to you today? And summarize in 1 or 2 sentences what you learned. If you have any questions, if you printed out the notes, you can write them over in this left-hand column. If you want to make notes to yourself on what some key points were, similarities and examples, differences and examples, something that you notice was repeated, you can also write in that left-hand column. And then once you feel like you are set with your notes, you can go on and do the practice for 2.4, part 1.